So it's still all about safety. We tend to overthink things or think we can do more than we really can. Just one more thing, then I'll go down and get another bottle of water out of the truck. If you're doing a residential attic and you're going to be up there for any period of time, do yourself a favor, put 2 or 3 garden hoses on your truck and 2 of the weeping hoses for flower beds. Set the hoses, the weeping hoses, on top of the roof at the peak and turn the water on just till the water gets to the edge of the roof. That will drop the temperature in the attic from $160 to 95. Be able to work and survive. Motors. What kinds of motors are there? What are the 3 that I said?
Was it electrical?
Electronic commutation motor.
Yeah.
There's a term for the coefficient when the air comes out of the grill and clings to the ceiling. It's about 17 letters and 2 vowels. Sometimes you can't tell, especially on the ECM motors, if they're working properly. The only way to tell is airflow and monitor. It may take 2 or 3 trips just to make sure it's hanging in there or stay for a period of time. Hence the stuff that's here. We'll see if we can check the system next door and find out how it's doing and what it's doing. Measure quick. You can input all the information that it needs, and it will tell you the efficiency, it will tell you all the psychometrics of it, which psychometrics are the temperature drops, the humidity removal. It gets into engineering. That will tell you what a system is doing, how it's doing. What the ductulator does is what size duct, how many cubic feet of air is going through it, at what pressure, and the velocity of the air coming out, which is important because if not only you can't get the air out of the grill, if you can't get it out with enough force, you will not get it across the room. Everything matters, right down to the size of the grill and where the grill is placed. I'm sure you guys know you never put a supply grill than 6 inches to the wall, preferably a foot off the wall. Otherwise, it will not circulate the air in the room correctly. Air is supposed to go all the way across the room, hit the outside walls, and fall down, unless you're in a major area like this. This one will shoot the air probably 8 feet before it falls. What is the definition of air conditioning? Basic principle of air conditioning is to move heat from one location to a less objectionable location. Heat or cool it, clean it, dehumidify it or humidify it. A properly conditioned space, you don't feel air. You just feel comfortable. I told you guys I had a doctor's office, 72 degrees, and you sweat. Shouldn't be sweating at 72 degrees. It wasn't properly designed for conditioning the space. For today, we're going to see if we can look at a system and have everybody get an idea of what's going on and fill in the blanks. What does a compressor do? What does a condenser do?
They turn liquid into gas, or gas into liquid.
Yes.
In the liquid. What does an evaporator do?
They turn liquid to gas.
We're good to go.
What's the purpose of ductwork?
To move it. Place to another.
Traveling.
How do you measure how much work an electrical device is doing? Actually, it's called an amp probe. They reach the amp. The amperage is how much work a motor, a device is doing, whether it be a light, a heater, a motor. How do you measure the pressure in a ductwork? That's a flow hood. It tells you the flow, it doesn't tell you the pressure. Exactly.
What is it?
Manometer.
Manometer? What the heck?
It's measured in inches of water column. You can tell how much air a system is moving
Oh, yeah.
by the pressure in the duct and the size of the duct. And it convert it to the actual numbers. It's a ductulator. Flow hoods will tell you how much is coming out of each grill. It doesn't necessarily tell you the whole volume that's in there unless you go grill to grill to grill and measure it all. Temperature has does play into the fact of the CFM coming out.
What's CFM stand for, please?
Cubic feet per minute. Stick the probe in, opposite airflow. It's called the P2. Little holes in the side that pick up the measurement. You get close, P2, you get exact. What's relative humidity? Relative humidity is the amount of moisture in the air that you can measure. There's two kinds of heat. There's sensible heat and latent heat. Latent heat is change of state. You don't feel that. When water starts to freeze, it gets to 32 degrees and it hangs there for a while before it drops below 32. And it makes ice. That's latent heat being removed and converting the state from liquid to solid. Sensible heat is what you feel. The more moisture that's in the air and the sensible heat decides whether it's going to be miserable or comfortable. The conditions to check refrigerant charge, there's wet bulb and dry bulb. The dry bulb is just what it says. A wet bulb, the old school way, is a sling psychrometer where you had to get, you wet the wick on the bulb. Distilled water.
Distilled water.
And you spin it around, and the bulb's on a thermometer, and you would check what that says against what the average, the standard thermometer said to get the wet bulb temperature. It matters for a critical charge. When you talk to tech support, most of the time they're reading the script. And they'll ask you a question and just go down a flow chart. If you have a mini split air conditioner and you have electrical issues with it, it communicates through AC and DC through the same wires. To catch where the problem is, you have to have an analog. You have to have the swing arm because you need to catch the bump, which also goes back to diagnosing regular refrigerant issues. Digital, expensive, steady. And analog, there's the swing arm. Which one will find more problems? What you wind up looking for is a bump.
Pump over you? Like
Yep, especially on the high side. If it's mixed refrigerant, it doesn't blend. If somebody worked on it and didn't pull a vacuum on it and left air in it or nitrogen in it, it's called non-condensables, it will not work properly. Analog gauges and analog meters have a buffering system in it. When you have non-condensables, it gets into the, no.
So will the needle fluctuate?
Yes, it bounces,
Okay.
and that's how you catch it. And sometimes that's the only idea you'll have, that there, what direction to go to find the source of the problem, where it'll just bounce every so often. Pull the charge out, evacuate, pull the charge out, change the dryer, evacuate it, and recharge with new refrigerant, and the problems go away. You can't mix refrigerants. Most of the refrigerants on the market today end in an A, and it's a blend. And when you charge it, you have to charge liquid. If you charge gas, you will ruin a whole tank of refrigerant because it's what's called fractionates. It's made up of multiple gases that have different boiling points, and when you turn a valve off, all that liquid refrigerant boils off, and it lets off gas, different amount of gas as it goes. So if you charge a machine with vapor off the top of the tank and don't turn it over, you won't get the right blend, and you just wasted a tank of refrigerant. Also, if you have a machine that has habitual leaks in it that you can't find over a period of time, 410A is a common air conditioning refrigerant, it will destroy the charge because it let off a little more of this gas and a little less of this, and you don't have the compound that was meant to be in the first place. You take your gauge off, the valve that's left to hold the refrigerant in is called the Schrader valve. It's the same valve that's in your car tire. It's not meant to hold anything in it for any period of time. It's meant for you to get whatever you have off of it until you put a cap on. A brass cap, not a plastic one. Never tighten the cap, lost charge. They hook gauges to it, and oh wow, look, the gauge says I'm right at the pressure I'm supposed to be. Doesn't mean you have the right amount of refrigerant, you're just in that window of area that's going to give you those pressures. Temperature of the refrigerant lines didn't matter to them, apparently. There was another way to charge these machines, it's called by approach, and it would have worked if the coils were clean. They weren't. I took out 45 pounds of refrigerant from one machine. I worked on 6 machines. By the time I got done, I used up what I recovered, and I still didn't have enough gas to fill the last circuit up. Temperature was right, but now I have control of the humidity and it dries the store out. We can go next door and put all the probes and all the toys on a machine if you want, and we can see how the machine's doing.
Yeah, well, you know, they
You
had
fit in.
chocolate chip and peanut butter.
Real well.
And they also had, not only that, they had,
Cookies over there.
those had,
On to that.
This pleated filter stops everything, including airflow. I'm short and old, tall guy. There.
I'm tall.
Return grill,
I'm not tall. I'm tall.
that's a supply grill.
That's
I'm tall.
Just installed.
Well, yeah, it's a return grill, so it's sucking up.
Does that mean that good?
I can let go of this.
That's how much air is going through. 2575, take it down.
It just barely makes it, man.
So what's the model number of the unit outside?
It's a pane,
The pain,
and it's PA4NAN dash.
7313.
And I'm not looking.
32.
at anything. There's a bunch of different numbers.
It's a 3-ton. How do you know it's a 3-ton?
Because by the serial number.
Look at it and say what size.
There's
it
a
is.
certain 2 numbers in that serial number that's gonna tell you the tonnage.
This was made the 28th week of
I
2000.
didn't-
So we had 2575 before.
What? I know. I don't know what
So it automatically comes on.
you stand.
So we got 2900 CFM. Divide by 600. What do you got?
25 by
Four
600.
with a carryover.
Yeah, for
So it's definitely pulling a lot more air than it probably should. So it's going to create an issue with temperature drop across the coil. Alright, so we're going to need other readings off of that.
Give me 2 numbers, you said 29 and then you said, what was it? The other one was, it was 25 or something like that.
That was just to show how much restriction a pleated filter does. Take out the blue probe.
What?
Take out the supply one.
I think much had you.
Put it back in. In favor, take out the red probe.
By 12.
So the supply pressure is 0.04. Come on down. Pat, what's the
No,
model
that's mine,
number?
Marky.
Yeah?
Michael,
No, I haven't.
November, April, 0, 3, 6.
Okay. Okay, so it does have a 3-ton air handler to it. All right, come on down. Somewhere should be the notes on what the standard supply static pressure is and the return pressure.
Supply is 0.05. Supply, static pressure is, for the supply would be 0.01.
0.05 return.
Yeah.
Yeah.
So 0.1 is the supply. We don't have enough pressure in that duct.
No.
Ductwork's the wrong size. So at one point, I would guess this was a 5-ton system and somebody downsized it. We can't get the pressure out of the ducts. We're moving too much air across the coil. The fan should at least be slowed down. With it going that fast, we're not going to get the right heat transfer across the coil. Not going to control the humidity correctly.
Return pressure?
The return pressure was 0.02.
0.02. I didn't hear that.
I didn't hear.
Until
So we need supply and return temperatures as well. Temperature probe up to the supply and return grill. You can put
Okay, that's before, no filter, that's.
quick non-contact thermometers to get your readings.
Static pressure.
Yeah, the static.
Static pressure on the supply.
Counts as you just use one of those guns.
What was the static pressure, 0.2, 0.02?
Return temperature was 0.02.
Yeah, 0.02.
Supply is 0.0.
Static pressure, I don't remember
Yeah.
getting that.
That's because you're up there.
Okay.
You're supposed to be down here.
So, difference, I know these two are the same, correct?
You got me, all right.
Yep.
Difference between the three.
what you did?
Relative
I'm gonna
humidity
look
and
and see.
temperature, air velocity, just the temperature.
Just the temperature, so I just want,
How far away can it be from?
I can almost tell you when it's gonna rain.
Grill, nobody put the filter back in, so will that make a difference?
No, you better to take all the readings without it.
75.5.
What's the return?
$69.5.
Alright,
Yeah, I
so
was
we
gonna
got
say, I was
53 for supply, what do you have for the return there?
What do you say?
Dave.
I got 70.
67.
67?
What was the supply? 52?
What was the supply?
52?
53.
53.
Okay, what was the return, 60? What's the
67.
temperature difference?
So the supply was
14.
53 and what was the other one? 67.
14.
Design temperature across the coil is 20. Minimum 16. We need to know what the supply pressure, the supply CFM was.
Yeah.
Have a flow hood to measure it with. It can be done with a, called a ductulator. Don't destroy them, please. Point 1 is the standard for supply.
Where's 0.1?
If the duct is 15 by 15, what is the CFM at 1 inch of water column? So line the numbers up. 15 there, with 15 there. And right there is your stack, is your CFM.
Cubic feet per minute.
Oh, yeah, per minute. Cubic feet per minute. 15 inch, you would have the other 15 on this line, you have to line them up. Where should the- There. And then we're gonna know what number. Here's your static pressure, 0.1. There's your CFM. We know we have a 3-ton air conditioner.
Yep.
So if it's 400 cubic feet of air per ton, how many CFM should we have had for that machine?
What?
1,500 out.
Yeah.
1,500, what?
Yeah.
Was
No,
that
that
right?
was an example if you
Oh.
didn't, if you didn't have a flow hood to put up.
Okay.
But it's a 3-ton air conditioner, you're supposed to have 400 cubic feet per ton. So how much air should we have had?
1200. 1200.
And how much did we have?
We had
2,900?
Yeah,
or 500.
Too much?
Yeah, I know.
Nearly enough.
so with that much volume of air going across the coil, you're not going to get humidity control, you're not going to get heat transfer.
But when does that matter though? Because in there, it's comfortable.
No, it wasn't.
Wasn't? You didn't think so? It was like, it felt like over here. I don't
No.
know.
Ideal humidity
Uh-huh.
is between 35 and 50% humidity. Between 35 and 50% humidity, I apologize, I forgot the exact number, it's either 96 or 98% of mold, viruses, and bacteria die.
Okay,
Your body can perspire like it's supposed to.
yeah.
Papers don't curl up. Mold doesn't grow.
Feel humidity, okay.
When the humidity climbs, that's when bad things start to happen. When you don't have the humidity control and you don't have the volume, we have too much volume of air, we don't have the pressure we need. Going back to what I was saying before, if we don't have the pressure, we can't get the volume of air out of the grills to push it across the room that we need, and it falls short. That creates issues depending upon the location of the thermostat, where the machine will bang on and off too many times. And not only does it jack the bill up, it beats up the contactor outside that turns the compressor on.
It went away, mine doesn't go away, it stays there until I click on it.
It's already sort of froze.
I think it's
74 degrees in or now, and it's 50% humidity. Probably the only saving grace over there with it, because it's a church, one unit is running. So that 3-ton is trying to carry the section next to it. Otherwise, it would have had a whole lot more issues going on than that. See, all the little details matter on what we find and what we do. You're gonna go out as a helper, you gotta set everything up and know where it goes. When Patrick climbed up into the ceiling, one probe went in the return and one went into the supply, pointed away from the air handler. That gave me the readings for the static pressure. Typically, you'll find that the return isn't big enough for the machine. The supply air gets too cold. The ducts sweat. The cabinet sweats. Moisture and droplets of water behind drywall or ceiling tile in Florida is not a good thing. Arizona, no problem. Getting to deal with a parts house is a good thing when you have a good parts house. You get tips and find out information that most people don't because they tend to share. Gotta be something.
When you
Who
went
thinks
up,
they can do it?
when you went up in the attic with the
Yes,
probes,
both P-tubes pointed away from the air handle. They
Right.
went into the duct and you point them away.
so
If-
they're not facing the air handler.
Correct. You need them going, they went to the left because you want them going opposite air path. You don't want them blowing into it. You
Right.
want them going away from it. On something that small, if it was reversed, it wouldn't matter. When you get into larger ductwork, then it's going to start to matter. They probably would have thought that it was close to what it was supposed to be because it had a pleated filter that's not supposed to be there, restricting the air. System's not designed for it. If you have to have a pleated filter in residential air conditioners, it has to be 4 to 5 inches thick to account for the pressure drop. 400 CFM difference across a filter, that's insane. Yeah,
What's the difference normally supposed to be?
to the point you actually looked at it and said, that's it? Because it's going to vary from filter to filter.
Right.
50 or 100 maybe?
More like 25 to 50 on a clean filter. Now on top of that, you have the filter that is restricting more air than it ever should on a return duct system. Air takes the path of least resistance. You're looking at issues of any breach in that duct is going to be amplified. It's going to suck more attic air into that system than through the filter, which is going to change the air going across the coil. You're going to be getting a lot more heat than you should during the day. You're going to be adding in a lot more humidity than you should. Worst case, if that system was sealed up tight on the return and the filter got too dirty, you wouldn't let the water drain out because you'd have so much suction on the return duct. In the return half of the system, you would hold water into that pan and it would overflow before it drained out.
Yeah, you're talking about changing the speeds. What are they, jumpers or something like that? Electrical jumpers or something like that?
That's
Change
actually
the
bad.
difference
Pull out a
between-
wire, pull out the black wire,
Okay,
put in a blue wire.
okay, so it's like a jumper or something like that there, right?
No, it's literally space terminal. You've got 3 wires, low, medium, and high, red,
Okay.
blue, and black.
So you just put it, whatever.
Just pull out the black one and push in the blue one.
Put it in the blue
Decent.
one, okay, all right.
The
Yeah,
fall
yeah.
arrest kit.
All right.
When are you supposed to wear a fall arrest kit?
It's on the top of a building?
Yeah, or when you're trying to jump off or go down though.
You're 6 feet off the ground.